Alright guys, I think I am live. Not sure. No viewers. Hopefully you guys can hear me okay. Well, I tried to record this earlier, but I realized I messed up in OBS. I'm still learning, so bear with me guys. Merry Christmas to you all. Some of you are getting ready for Santa right now. You parents out there who are putting stuff under the tree with care. Sugar plum fairies and whatnot. Merry Christmas to you all. And a happy late Saturn-Jupiter conjunction, and also a happy late solstice to all you pagans out there. It's nice to be able to see you guys again. Have a little bit of free time tonight, so I figured I'd re-record this video. Talking about superfluidity, superfluids. This is along the similar ideas of a superconductor that was discovered around the same time. It behaves in a way that it defies logic. It defies what we have conceived of as physics. Superfluids are most common in the form of helium-4 on planet Earth. Helium-4 has 2 neutrons, 2 electrons, and 2 protons. And whenever it's cooled down to about 2 Kelvin above absolute zero, so colder than the deepest, darkest parts of space, these molecules start to behave in a weird way, these atoms. They sort into groups and start to behave with a singular conscience. And a unique property of superfluids is they lack all viscosity. Whereas typically, if you take your finger and stick it into a bowl of water and spin your finger around that bowl, it will make the water rotate. Just pull your finger out and it will continue to rotate, but it slows down because there's friction between the water molecules that makes it not only friction between the water molecules themselves, but the sides of the bowl. You see, superfluids don't behave like this. If you were to stick your finger into a bowl of a superfluid, even though you'd freeze your finger off and start to spin it, it would rotate and rotate and rotate. You pull your finger out, and it would continue to do so. This is much in the same way that something, whenever it gets pushed through the vacuum of space-time, it will continue to move with no resistance because it is without viscosity. It's without friction. So in the way that the universe works, similar to the way that a superfluid works. And scientists over the last 10 years or so have determined that space-time, the fabric of space-time itself, is a superfluid. Superfluids do other weird things as well. Here's some helium-4 that we see being cooled down to about 2 degrees Kelvin, and you'll see it start to boil as all of the contents of this vessel start to equalize in pressure and in temperature. You can also make a superfluid out of helium-3, but of course, since there is only one neutron, it takes much lower temperatures, fractions of a degree above absolute zero. See, this is a superfluid. Superfluids behave in such a weird way, they actually climb up the sides of any surface you put it in, defying gravity. It will climb the walls of any container that you put helium-4 inside of. Another weird thing is you see quantum effects in superfluids, like quantum tunneling, the ability of a subatomic particle to move through matter. You can see that these superfluids actually can't be held within a vessel because these atoms are so neatly packed together, they'll slide right through the atomic instability within glass, so no container can hold it. And right here you will see the water, actually, not the water, the helium-4, the superfluid, climb up the sides of this container and drip off the bottom, defying gravity. So in this weird substance, this superfluid, we have gravity defying, we have the ability to have a fountain that literally never stops because it has no viscosity, no friction. You could create a perpetual motion machine using helium-4, using a superfluid. And the fact that you can't even hold it within a vessel because it will slide right out the bottom of it because its atoms are so much more neatly packed together than the atoms of the glass vessel you try to put it in, is a visual display of quantum tunneling in a macro form. Like I said, weird stuff. The universe itself is a very weird place. It's not like it looks. Our galaxy, for instance, is not just a flat disk of matter that circles around a supermassive black hole. Actually, it looks quite different. It's toroidal in shape, and I'll show you that now. This is the energetic shape of our galaxy. It almost looks like a flame rising out of the North Pole of the supermassive black hole we have in the center of the galaxy right here, and a flame coming out of the South Pole as well. These are actually bubbles of cosmic energy. This small one right here, this is actually a Fermi bubble. It's made mostly out of gamma energy. We knew about this for quite a while. However, we haven't been able to get good X-ray images of galaxies up until we launched this satellite called Rosetta satellite. That's what this bigger bubble, the large part of the flame, is called. The Rosetta bubble. It was just discovered within the last few months. This is made out of X-rays. This is the energetic presence of our galaxy. Our galaxy is shaped like the human energetic field. It's a chakra system. At the top, you have the crown chakra. At the bottom, you have the root chakra. In the middle, you have the heart chakra, the supermassive black hole that literally holds our whole galaxy together. Like our sun holds the planets of our solar system in constant gravitational dance around it, the supermassive black hole in the center of our galaxy holds the whole galaxy in its sway. This elaborate ballet, this spinning disk, is not all there is. There is this gigantic 10,000 light year tall pillar of energy that is invisible. The galaxy itself is more elliptical in shape. A large part of that football shape is dark matter, matter that we can't see for whatever reason. These could be rogue planets that don't have stars to illuminate them. This could be not so dense clusters of gas that aren't illuminated by any nearby stars and thus appear dark and don't emit a whole bunch of radiation. But with the Rosetta satellite, we could actually get images. This right here, this large bubble, is the image that was captured by this new satellite. This is the Rosetta bubble. And you can see this is the accretion disk of the galaxy itself. And look how much wider it actually is. The majority of the mass of our galaxy is not in the disk itself, even though that's where almost all the stars are. The galaxy is much different than it looks, and the universe is a lot different than it looks as well. The empty space between galaxies is not as empty as we once thought it was. Just because it appears dark and there's no stars, it doesn't mean there's nothing there. Actually, there's a very intricate web of gas that was pulled apart from galaxies as they died, that was stretched out of galaxies as they were colliding, and grew out of galaxies as they were forming, connecting all of the galaxies together in this highway system, this network, this matrix, this web that is invisible to us until we have the right equipment to look at it. This is what our universe really looks like. These little nodes, these little bright spots within this web are galaxies. And the tendrils that connect all of these galaxies together are fine filament style threads of gas in these huge trails that connect every galaxy together, like neurons in a brain. This means that whenever we choose to travel to these other galaxies in the future, it won't be nearly as impossible as we once thought. It's a lot more intimidating traveling through the desert with no gas stations for hundreds of miles. That's what it's like traveling between two galaxies when there's nothing between them. However, since now we discovered these filaments of gas that connect all of these galaxies together, it's like putting gas stations along our route. So it's something much easier, much less intimidating for humans to get from one galaxy to another. Also, we can convert that raw gaseous matter by changing the amount of protons, electrons, and neutrons. We can convert it into different forms of matter, basically using it as fuel, being able to change it into whatever material we need and synthesize matter. Think the replicators from Star Trek, converting raw matter into whatever you choose. Now we have the ability to do that because there is this baggage train of gas between galaxies that we cannot observe with our naked eyes, but is connecting all of it together. Everything's connected. Everything is energy and vibration and frequency. And there are threads that bind everything, invisible threads that we cannot see. This gas is only visible whenever you pick up the small, minute amount of radiation that it puts off. Without being able to see that small, minute amount of radiation, you're screwed. You think that the universe is a whole bunch of islands amidst an inhospitable sea of vacuum. It's not. The universe is alive and thriving. It's a network, like your brain or like your human body. Speaking of networks in space, recently they found another WOW signal. This is a signal that is produced by seemingly technological means from outside of our solar system. And this is particularly interesting because the signal was at 892 megahertz. 892 megahertz is not produced naturally. Whenever you have things like cosmic radiation or solar flares, whenever it produces a frequency, it's always spread throughout a huge cluster of the energy parabola, and it takes up multiple hertz worth of bandwidth. This is far different. 892.002 hertz, megahertz to be specific. The only thing that we have on Earth that we postulate we would even use this frequency for is fiber optic communication, really advanced, as fast as light communication that doesn't degrade and is instantaneous, basically. And the scientists that released this information, these leakers, said that it was not only 892 megahertz, but it was blue shifted, meaning it was traveling closer to us. And the most interesting part of all is that this signal came from Proxima Centauri, which is only 4.26 light years away, one of the closest solar systems. And it's a red dwarf, and we know for a fact that there is a exoplanet within the habitable zone, the Goldilocks zone of this planet. It's called Proxima Centauri b. And there's also a third planet that is farther away from the sun that is probably an icy planet. But this signal, they do this type of satellite telescopic reconnaissance where they bob up and down the receiver. And the signal was only coming from that one star system, which rules out the fact that it was somebody with a misbehaving cell phone or a microwave that was malfunctioning. This is a signal of an advanced civilization using fiber optic technology on a star system that it is a red dwarf star, meaning it lives a lot longer than our yellow midlife star. It is a lot less chaotic. It does have intense solar flares, but it will not die. It will not go supernova and destroy the entire solar system for a long time, meaning that you have the possibility of intelligent life evolving over a much larger period of time than you have on a yellow main sequence star like Sol, like our solar system star. This is really exciting. This means we have a signal coming from one of our closest neighbors in a planet that is probably habitable around a star that will live way longer than our star will. This is how we survive the apocalypse. This is how we survive our sun exploding, going supernova, and taking out all planets up to Mars. Our civilization will only live as long as our sun lives until we spread out to other stars. And our closest neighbor is now exhibiting signs that they may be already inhabited by spacefaring. Not just spacefaring, but spacefaring and coming in our direction extraterrestrials, which I think is really exciting, folks. So maybe we have 3 wise men coming this way to announce the birth of an enlightened world. Who's to say? But I've gone on here for about 16 minutes, so I guess I will jump off. It was a pleasure talking to you guys. Have a very, very Merry Christmas and a very Happy New Year. And I will get back on tomorrow and talk to you guys on Christmas Day as a bonus present to you guys. Thanks for tuning in. I hope the